Hey guys, this is Charu here. I welcome you all to my CP Tech channel. In the last video, we have seen the properties of concrete. In this video, let us know about the methods of design adopted while solving the problems. So, here these are the three methods used while designing. That is, Modena ratio method, or also called as a working stress method or elastic method of design. The next one is the load factor method, or also called as a ultimate load method or ultimate strength method. The last one is the limit state method. Now, let us see one by one. Working stress method, WSM, is also called as a elastic theory or classical elastic theory or a traditional method. It's not only designed for RCC structures, but even for structural steel and timber design. This method helps in restricting the stresses developed in the materials such as steel and concrete due to the working loads acting on the structure. With this, it ensures the safety of the structure. Main assumptions made in this method is linear elastic, where the stresses under working loads are kept within the permissible stresses and are found to be realistic. Here, the factor of safety is nothing but the ratio of strength of the material to the permissible stress. The factor of safety for concrete is taken as 3 and for steel it is 1.8. Let us view the merits and demerits of this method. Advantages. This design is adopted for large sections of structural members. Using this method, it offers a good serviceability performance under working loads. Using this method, it is necessary to determine the service stresses and as well the serviceability of deflection and cracking. Moving on to the disadvantages. Adopting working stress method will not provide the exact strength or the true factor of safety of the structure under failure. The modular ratio design gives higher percentage of compression steel than the limit state method, which is quite uneconomical. The long-term effect of creep and shrinkage, the effect of stress concentrations and other secondary effects results in significant local increase in a redistribution of the calculated stresses. This method fails between the types of loads that act simultaneously but have different uncertainties. Next is ultimate load method, ULM. This method is also called as a load factor method or a ultimate strength method. This method is completely based on ultimate strength of RC component or structure at ultimate load, which is obtained by developing the service load by some factor called as load factor. In this method, the stress condition at the site of impending collapse of the structure is analyzed and the non-linear stress strain curves of concrete and steel are made use of. This method generally results in more slender sections and often economical designs of beams and columns. In particular, when high strength reinforcing steel and concrete are used. However, the satisfactory strength performance at ultimate loads does not guarantee the satisfactory serviceability performance at the normal service loads. Now, let us see the merits and demerits of ultimate load method. Advantages. This method adopts the non-linear stress strain curve. Load factor provides the margin of safety against collapse. It allows different load factors for varying loads and the combination of it. The failure load computed by ULM matches with the experimental results. This method is based on the ultimate strain and utilizes the reserve strength in the plastic region. Disadvantages. This method does not consider the deflection and cracking. As discussed before, using high-strength reinforcing steel and concrete, it results in increase of deflection and cracking. As well, the creep and shrinkage is also not taken into account. Moving on to the limit state method, LSM. LSM aims for a comprehensive and rational solution to a design problem by considering safety at ultimate loads and serviceability at working loads. It provides the acceptable limits for the safety and serviceability requirements of the structure before the occurrence of failure. They ensure that this method will not exceed the limit states and does not become unfit for the use for which they are intended. The structure will not try to fail or collapse by exceeding the limit states. If there is going to be a failure, then it clearly states that limit states of structural has been exceeded. Merits of LSM. Limit state of collapse mainly deals with strength, overturning, sliding, buckling, fatigue fracture, etc. Whereas in WSM, it deals only with cracking, vibration, and deflection. The stress and moment redistribution are used in the analysis, and factor of safety are more realistic, which is used in the design. This method is said to be economical and also by providing a good appearance to the structure. So there are two methods in LSM, that is collapse and serviceability, limit state of collapse. It could be assessed from the rupture of one or more critical sections and from buckling, which may be due to elastic bending, torsion, shear, and axial loads. Limit state of serviceability deals with cracking and deflection under service loads, under working environment during their anticipated exposure conditions. Permissible stresses is defined as the ratio of ultimate or yield strength of materials to the factor of safety, where factor of safety is a number used to determine the working stress. The material defects, unforeseen loads, unskilled workmanship are taken into account. So therefore, factor of safety, FOS, that is equal to ultimate stress by working stress. The factor of safety used for steel and concrete is 1.15 and 1.5. Moving on to the characteristic strength of materials. This means the value of the strength of the material. As per IS 456-2000 code book, the minimum accepted percentage is 5% for RC structures. That is, there would be a chance of actual strength being less than the characteristic strength by 5%. From the distribution curve of strength material, the value of K corresponding to 5% area is 1.65. That is, characteristic strength that is equal to mean strength minus the constant into standard deviation. Here, characteristic strength of concrete is denoted as FCK and measured in terms of Newton per mm square. There are various grades of concrete such as M15, M25 and many more. M stands for mixed designation of concrete and number refers to the characteristic compressive strength of concrete at the age of 28 days. The next one is characteristic strength of steel, which has the minimum yield stress or 0.2% proof stress as per highest specification and expressed in Newton per mm square. So guys, I hope this video would be useful to you. In the next video, let us see how to solve the problems using these methods. With this note, I would like to sign off. If you like this video, kindly share it, like it, and subscribe our channel. Thank you.